if you turn on radio these days, the average song length will be 235 seconds. No. And yeah, that's going to be the average length. But the question is, if that's the true mean, every time you sample 64 songs, can you imagine if you got 235 as the mean every single time? That would be like having some Chips Ahoy, a box of Chips Ahoy, and can you imagine if every box of 64 cookies had the same average number of chocolate chips? No, that would be the craziest thing in the history of the world. The sample mean is a random variable. It varies. We can't predict what it's going to be with certainty. We can't. Somebody says to you, well, what's the sample mean? What's it going to be before you sample? I don't know. Say, well, we give up. You say, no, we don't, because it's predictable. Follows a normal distribution. That's the central limit theorem. When the sample size is 64, we're going to do some more, right? So part G, n equals 64, what would the z-score be for 255? So we're going to figure out the z-score here in part G. That's going to be z equals the value that we want to standardize. We're going to put that first, and then we're going to subtract the population mean, 235. And then we're going to divide by the standard error, which is going to be 45 divided by the square root of 64. And that whole mess is going to simplify to 20 over 5.6. So if you didn't know, I'll tell you this right now. 255 deviates 20 seconds from 235. You knew that. But how many standard errors away is it? And that's why we learn statistical methods, because we need to know these things. We want to pay attention to unusual things. The question is, would this be unusual? Part H, would this be unusual? Well, it just says compute and interpret. I mean, there's a lot of ways to interpret this. So I'll go for this one. If we have 64 songs, right? If we have 64 songs, it would be crazy to think the mean, and that's the sample mean here for these 64 songs, the mean would be more than 255 seconds. Right? Next time you're playing Monopoly, well, have friends play Monopoly with, you see them and they're rolling the die and they say, oh man, I'm really nervous about getting snake eyes, which is just the two looking up. And they roll snake eyes and they say, oh man, I'm worried to roll again because you get to roll again. Right? And then maybe they're like, oh man, what are the chances I get snake eyes 3 times in a row? Would you like, oh, I'm freaking out over here. You'd say, you probably don't have to worry about it. The reason why is this is very, very unusual, right? A z-score of 3.57 is really unusual. In fact, it's not even on the table. Because the table, it only goes out to, I think, again, I don't have my z-score table handy, but this is a good lesson. Draw the picture. You draw the picture, because this one I know very well. Whenever I have a z-score that's like 2 or 3, I really, really pay attention. How about this? I just want you to estimate what the answer is in part H, and that'll lead you to the answer in part I as well. what's the probability of part G happening, right? What's the probability? Hey, before I roll these die, can you tell me what the chances are of rolling snake eyes 3 times in a row? Should I be worried? No. So I would say here the probability of a sample mean being less than 255 is the same thing as saying, what's the more than, that's part I. That's going to be part I. Which I'll tell you right now would be, if we're going to approximate that, the complement of part H, I, and then HI. H is over here. The probability that the sample mean is less than 255 equals the probability more than 255. More than 255. I'm just going to write the z-score now. See? These things happen. Z is more than 3.57 equals, I'm just going to estimate to 4 decimal places here, 0.000. Now you might want to put another 0 there. Fine. I'm going to put a 1 there because that's what I want to do. That's a 1 in 10,000 chance. And really we'll say in hypothesis testing it's less than 1 in 10,000 chance. So imagine if somebody told you, listen, the average length of songs on the radio, it's 235 minutes. And you sampled 64 songs and you got, how about something like a sample mean of, I don't know, 258 seconds. Wouldn't that maybe provide some evidence of something there?